Okay, in this video we're going to talk about solving quadratic functions by factoring. The first thing you need to know is when do you use solving by factoring? Okay? When the question asks you to find the roots, to find the solutions, to find the x-intercepts, which are these points on the graph right here of a parabola, to find the zeros, and then lastly, when you're working on a word problem, talking about launching or throwing something into the air, you're looking for it when it hit the ground. That's what solving a quadratic function finds. These x-intercepts right here are also known as the ground in real life. A basic principle of solving by factoring is using the zero property. Okay? A times 0 equals 0, 0 times A equals 0, and 0 times 0 equals 0. Basically, it's saying that if you have things that are multiplied together and they equal 0, at least one of these has to be 0 also. So, let's look at the first basic concept that you have to understand about solving by factoring. Okay? So if we look here, we have x plus 3 times x minus 5 equals 0. Following that concept that we just learned about, the zero property, in order for this to equal 0, either x plus 3 has to equal 0, or x minus 5 has to equal 0, or they both equal 0. So, what you'll do is, you'll start out by taking the very first factor here and setting it equal to 0, because either this equals 0, or this equals 0. And then you'll subtract 3 from both sides, because you'll solve it like it's just a regular old mini equation, and you'll get x equals negative 3. Okay? Now, there is a shortcut version. I will actually solve all of these by the long way, but I would like you to know that there is a shortcut. If you'll notice, the answer is negative 3. Well, you see the 3 here. This is the same 3, and notice how it's the opposite of what you see there. And that's going to happen every single time. It's always going to be the opposite of this divided by whatever number is in front. See how we don't have a number here? Then we don't divide it by anything. So it's just negative 3. So using that same concept for this one would be x equals, and then the opposite of this is positive 5, and we divide by nothing because we don't have anything here to divide by. So our answer would be x equals 5. But let's see how we get that. So you take x minus 5 and set it equal to 0 also, and then you add 5 to both sides. And then what do you get? X equals, and 0 plus 5 is 5. Okay? So now, I would like you to pause the video, try to answer example 2 on your own. Assuming that you've paused the video, you're now restarting it, and you should see that your answers will be x equals positive 8 and x equals negative 19. And then just to show you how you got that, you go x minus 8 equals 0, x plus 19 equals 0, and then you got plus 8 plus 8, and then that cancels out. It gives us 0. So you get 0 plus 8 is 8, and here you'd subtract 19 equals, subtract 19, you don't really need that. Okay, and that gives you 0, and 0 minus 19, negative 19. Another way that you may see this written is they'll use curly brackets, and you'll put negative 3 comma 5 and close the curly brackets. Okay, and down here you'd see 8 and negative 19, close the curly brackets. Okay, try not to ever use parentheses, because that would indicate that it's a point, and these are not points. These are just answers. Like you're telling us that the answer is 5, the answer is negative 3. The answer is not the point negative 3, 5. Okay? If anything, if you wanted to write it as a point, it'd be negative 3, 0, and 5, 0. But that's getting into a different concept of the x-intercept. As long as you know that this is negative 3 and this is 5, you're okay. So let's take it up a notch. Let's see, what if there was a number in the front? Okay? Well, I told you before with the shortcut, if you want to go straight to your answer, you go x equals, it'd be the opposite of negative 5, which is positive 5, divided by the number in the front, which is a 2. So your answer will be 5 over 2. Okay? And here, your answer would be x equals the opposite of 7, which is negative 7, over, and then the number in the front, which is a 3. And since neither of these will reduce, that is the answer. So let's see how you'd get that. Well, you would take the 2x minus 5, set it equal to 0. You would add 5 to both sides. You get 2x equals 5, and then you'd have to divide by 2 to both sides, and thus leaving you with 5 over 2. Okay? Same thing here. You take 3x plus 7, set it equal to 0. Subtract 7 from both sides. 3x equals negative 7, and then you end up dividing by 3, and you end up with these two answers still. Okay? So pause the video, try example 4 on your own. I'm assuming you've paused the video now, and you've come up with your answers, so just double check. This should be positive 5 over 3, and x should equal negative 13 over 11. Okay? And so you do 3x minus 5 equals 0. You add 5. 3x equals 5. And then you divide by 3. Divide by 3. And you get 5/3. And then here, you do 11x plus 13 equals 0. You subtract 13. 11x equals negative 13, and you divide by 11, and you end up with the same answers either way. I strongly encourage that you learn how to do the shortcut method, because it will save you time and you'll have to write less work. Okay? Now, sometimes when you factor it, it'll look like this. Okay? Same concept. What are the two things you're multiplying here? T and t plus 6. So you'll still set t equal to 0, and then t plus 6 equal to 0. And then this pretty much gives you the answer t equals 0 for one of them, and that will work every single time that you don't have it in the parentheses. If it's just a number or anything and a t, then t really is just going to equal 0. Okay? And then this, you would still do the same concept, the opposite divided by whatever's here, and so you should get t equals negative 6. Okay? And if you subtracted 6 from both sides, that's what you would get. Okay? So you try this one, pause the video, and then try it on your own. So you've unpaused the video now, and we're going to answer this question. So what's being multiplied together here? Well, you have 5t, which you'd set equal to 0, and then you'd have 3t minus 2 equals 0. Well, this one you would just divide by 5 to both sides, and you'd end up with t equals 0, or you could have solved that it's just a t on the outside with no addition and subtractions on it, and it's just going to be 0. Okay? And then here, you do the opposite of this number, which is positive 2, divided by the number next to t, and you get 2/3. So if you added 2, you get 3t equals 2, and then you'd have to divide by 3, and thus leaving you with this same answer. Okay? Now, what if you get a question that's not in the factored form? Okay? Well, it's your job to put it into factored form. Okay? So step number 1, you need to make sure the problem equals 0. That's a must. So see how ours equals 0? Step 1, check. Step 2, you need to try to take out a GCF. Ultimately, in the grand scheme of things, it doesn't dearly hurt you if you don't take the GCF out when you're solving by factoring, but it's always a good thing because it makes your numbers smaller and it's easier for you to work with. Okay, and you don't have to reduce your fractions at the end. Okay. Step 3, if it's a binomial after you've taken the GCF out, you want to try to take the difference of squares factoring. Okay. And then you're going to look for even powers and perfect square numbers and a subtraction sign. If it's a trinomial, you want to try the X factor method. If you need help with the X factor method, you can continue to look at the problems ahead, or there's another video that's linked near this. And then step 4, you'll set each factor with a variable equal to 0 and solve, just like we did in the previous examples. Okay, so let's do that with this question. So first you look to see, do they have any numbers in common? Well, both 3 and 9 have a greatest common factor of 3, so you'll pull a 3 out. Then they both have a t, so you can pull at least one t out, and the smallest exponent is 1, so that's the one I'll take out. And then what's left over? Well, 3t times t equals 3t squared, and 3 times negative 3 is negative 9, and then we don't need a t, and that equals 0. Well, this looks like example 6 from the previous question, and so you'll set 3t equals 0, and t minus 3 equals 0. And if you look at step 4, I made a note of saying set each factor with a variable equal to 0 and solve. Sometimes when you take a GCF out, there's not a variable on it, so there's no point in setting that equal to 0 because it doesn't have a t in it. So now that these are set equal to 0, you'd solve. Well, t equals 0 here, and then t would equal positive 3. Okay? And so those would be our roots, solutions, zeros, x-intercepts, and the time when it hit the ground. Okay? Try example number 2. So, we have a question that looks like this. Sometimes it will give you the function, and then it wants you to find the zeros, find the roots, find the solutions. And you have to understand, where it says find the x-intercepts. And you have to understand that you're supposed to take this function and set it equal to 0. So really, that just wants you to take f of x and make it 0. So you're going to write it however you want to, but ultimately take all of this stuff and set it equal to 0. Most of the time people like to have the equals 0 on the right side. It doesn't matter one way or the other. So you do whatever is comfortable with you. Step 2, we need to take out a GCF. Well, is there anything that goes into 18 and goes into 50? And that's a 2, so you can pull a 2 out. Okay? Do they both have a letter? No, they don't, so you can't take a letter out. So now you look to see it's a binomial. You're going to try the difference of squares. Well, do we have subtraction? Yes. Oh, I haven't even GCF'd out yet. So take the 2, divide it from everything. So you get 9m squared, and minus 50 becomes negative 25. Because really you're just dividing each thing by 2. 2 times 9, 18. 2 times 25, 50. Okay, and this still equals 0. So now this is where you would try, it's a binomial, so you would try to see if there's difference of squares. Well, there's subtraction, that's the first thing you got to look for. That's an even power. 9 is a perfect square because it's 3 times 3, and 25 is a perfect square because it's 5 times 5. And so this will end up breaking down into 2 parentheses, and you want to start with the left term and break it down. Well, we know it broke down into 3 times 3, and then take half of the exponents that they give you. So they give you a 2, so half of 2 is 1. So you put 1m there. And then now we're at our sign, so you put a plus and a minus. And then 25 breaks down into 5 and 5. Okay? And then our 2 will come down, equals 0. So step 3 completed. Now we're going to set each factor with a variable equal to 0 and solve. Okay? Well, 2 is a factor, but it doesn't have a variable on it, so we're not even going to worry about it. So we'll take 3m plus 5, set it equal to 0, and 3m minus 5 equals to 0. Okay? So you should know by now that this would be negative 5 over 3, and then this one would be positive 5 over 3. But you subtract 5 from both sides, you get 3m equals 5, and then you would have to divide by 3. Oops, negative 5. And then you'd have to divide by 3, and that would give you negative 5 over 3. Here you would add 5. And then you would divide by 3 and get 5 over 3. So your answers, your solutions, your roots, your zeros, your ground, your x-intercepts are negative 5/3 and positive 5/3. The last question that we're going to go over is one like this. Now I tried to make it as difficult as possible. So this is one where it's not in your normal form of the ax squared plus bx plus c, okay? And we'll actually have to do something for step number 1. So step number 1 says make the problem equal to 0. Well, this definitely doesn't equal 0. So what you've got to do is you have to move everything to the other side. Now you want to try to move everything to the side that has the square term on it. It just makes it easier, and it also makes it easier if you can make the squared term positive. Okay? It's easier to factor with positive numbers. Okay? So first thing I'm going to try to do is move this 1. And so if it's a positive 1 over here, you got to move it by subtracting it, or think of it as if it's positive over here, it'll be negative over there. And you want to put it underneath its like term. If it doesn't have a like term, you just make a new spot for it. Okay? Well, this is like 3 because they're both constants, or just numbers without variables. Okay? And so I'm going to bring that down, and I'm going to do this step by step. You can really move both of these at the same time, but for everybody's purposes, I'm going to do it in multiple steps. So now negative 3 minus 1 is negative 4. And then 1 minus 1 is 0. And then the negative 10m comes down. Now it still doesn't equal 0, so I need to move this over to the other side. Okay? So if it's a negative 10m over here, I'm going to need to add it over here. So I add 10m. Now, notice how I put it in between these two? Because this is an m squared, and this doesn't have an m, so it doesn't have a like term. So we actually need to put it in the middle right here in this zone, because we want our letter that doesn't have an exponent on it in the middle. Okay? So the 24m squared will come down. The plus 10m will come in the middle. The minus 4 will be there, and it should equal 0. And it does. Okay? So now I know that looks like it's a lot of work. It's really not that hard once you understand the concept of how to move, and you should, if you practice it enough, be able to do both of these at the same time where you won't have to do multiple steps like we did here. Okay? So now we move on to step 2. We need to take out a GCF if there is one. 24, 10, and 4 all have a 2 in common, so we'll pull out a 2. They don't all have the letter M, so we can't take out an M. So now just go through and divide everything by 2, or 2 times what equals these things. And so you get 12m squared plus 5m minus 2 equals 0. Okay? Well, you'll see that we have a trinomial, so we need to try the x factor method. Okay? So I go and I make my x, and you do the a times the c, so it'll be 12 times negative 2, which is negative 24, and then our b goes on the bottom, so that's a 5, and it's positive. Okay, so I need the things that will multiply to get me negative 24 and subtract to give me 5. Well, that's 8 and negative 3. So 8 minus 3 is 5, and 8 times negative 3 is 24. Okay? So now, I'm going to bring my 2 down, okay? And then I'm going to draw my factors here, okay? You take the A and the letter, or half of the letter here, and you do 12m, and then plus 8, and then you do the A again with half the letter, and minus 3. Okay? And then you're going to see, do 12 and 8 have anything in common? Yeah, they both have 4 in common. So you're going to divide this by 4. And so the 2 comes down, you get parentheses, and 12 divided by 4 is 3. And 8 divided by 4 is 2. And then do 12 and 3 have anything in common? Yeah, it's a 3. And 12 divided by 3 is 4. And then 3 divided by 3 is 1. And so these are our factors. And then remember, they equal 0. Okay? And so now, step 4, set each factor with a variable equal to 0. Okay? Well, 2 doesn't have a variable on it, so we're not going to set that equal to 0. Okay? So you could set each of these equal to 0, and you should see that you get m is negative 2 over 3, and m equals positive 1 over 4. Okay? Because 3m plus 2 equals 0, subtract 2, and you get 3m equals negative 2, and then you divide by 3, so you get negative 2/3. And then 4m minus 1 equals 0, plus 1 plus 1, and you get 4m equals 1, and you divide by 4, and you get 1/4. Okay? So that concludes my video on solving by factoring. Feel free to use this with any of your solving by factoring questions. Have a good day.